Hello, everybody. Welcome on the Lights on Data show. Today, we're going to talk about reinventing near real time digital and content analytics with data virtualization. And we're actually going to see a quick demo at the end. So, stay tuned. Last 20 minutes or so, we're going to see how we can do a quick build. I say we, but it's really all Ali here. And I do have the pleasure of introducing him to you. So, Ali Aghatabar is the founder and director of Intelicosmos. He has been helping clients across the globe, really, particularly in the Asia Pacific region, for over 2 decades. With a consulting background, he helped a wide range of clients and industries for their IT needs, especially on data analytic, cloud architecture and computing, AI and process automation, digital transformation, IoT and smart devices, and so much more. Partnering with Lyftrondata, Ali and his team in Intelicosmos are helping APAC clients to realize the true value of their data and leverage data for running a better business. With a team of excellent data, cloud, and AI subject matter experts, Ali is helping clients to get them into the business of the future. Welcome, Ali, on the show.
Yeah, thanks, George. I appreciate the opportunity you gave to me. And thanks to all the audiences. It's my pleasure to actually be here and walking you through one of the use cases we have done, and we found this actually useful for the community as well. And if it's okay, I can jump to my slides and
Yeah, I'll bring them up. Thank you so much for that,
yeah.
and I'd like to encourage everybody to ask questions. We're gonna try and get to them towards the end, but please put your comments in there and let us know where you're joining us from. All right, off to you.
Yeah, thank you. Uh, the topic is reinventing near real-time digital content analytics with the data virtualization. So the two main topic is data virtualization itself as a general topic in the data, and of course implementing that technology or approach for the digital and content analytics use case. We do it almost like a near real time. So we do have some topics for today. We will talk about data virtualization itself. Then we go to digital and content analytic use case. What is that actual use case itself?
Mhm.
And after that, we will talk about the top strategy we actually use for our digital and content analytics. Why actually those strategies are important, and how we actually going to tackle them. And at the last, we have three steps actually. We have already built a demo solution, which I will explain the solution itself, and then I will explain the solution in the platform, which has end-to-end from the start up to the end, including the advanced analytic. We give you 10 minutes break, and after the break, we try to replicate the demo solution from scratch by hands-on experience. So if somebody is interested to understand how this solution actually been built, we actually walk you through on the last 20 minutes as well. So let's start with the data virtualization. So what is data virtualization? In the current data platform environments, approaches, or the industry, uh, to be able to get data as an asset and use it for analytics and advanced analytics and give feedback to the decision-making systems, we normally get data shuffled around a lot of storage or databases, and we use a lot of ETL tools to actually move data from different environments to another environment, massage the data, transform a little bit, and get the next level of data, and then repeat this cycle a lot of times to make sure it's in the position which we can use for analytic. But this cycle is very expensive, it's time consuming, and it needs a lot of expertise and technology as well. All the ETL tools like SSIS, Informatica, and a lot of tools like this, they are expensive, needs a lot of SMEs, and it takes time to develop as well. But till we developed, actually the requirement changes. These days, business actually changing so rapidly, and uh, repeating this cycle is very, very hard. With
Mhm.
data virtualization, we're actually trying to remove the ETL problem and make sure the data sits where it belongs to. I mean, it could be uh, any environment like just once I might get my battery actually plugged. Sorry.
Yes, no, please go ahead. Let's see. Want to say hello to Anna Zita here. Welcome from Romania. I'm from Romania too, so welcome. And Mutina, this is amazing information and details. This session should be often and also show an exhibition. I agree. It's very educative. Let us connect as we grow and develop. Well, thank you so much for your comment, Mutinda. It's a pleasure to have you here attending the show, and I look forward to learning this more with you as well, as Ali will present more on this data virtualization experience. And stay tuned as it will be quite hands on. All right. So I'm curious if anybody from the
Sorry,
audience.
everyone.
No problem.
Sorry,
Welcome back.
everyone. Yeah, no worries. I mean, uh, so let's back to the slide if possible.
Yeah,
So with
let's get the
data
slides.
virtualization, yeah, sorry for interrupt. For data virtualization, we let data to sit where actually it belongs to. It could be, I mean, at least the platform we're using 300 uh, big data providers, they can get data where actually with their own platform. Data virtualization just build some sort of pipes to these data sources and bring them as a objects as a virtual object in the platform, which we can actually play a lot. So we don't do ETL unless it's necessary. It means 80-90% of ETL actually can be removed.
Hmm.
With the data virtualization, you can have your own advanced analytic tool, whether it's a Google Collab, Jupyter, Kaggle, whatever actually advanced analytic tooling is available. You are able to actually plug it to do this data virtualization as well. And the reason for that one is data virtualization actually has API, ODBC, and JDBC connectivity. Visualization actually is easy because your model is in the data virtualized environment, and you can just plug your visualization tools like Tableau, Power BI, Excel, click everything into this virtual environment. So you don't need to build your data model in each of these environments, which, for example, the model is built in the Power BI, can't be used for Tableau. So with the data virtualization, virtual data model actually is centralized. Everyone can just plug it to this virtualized environment, and then they have the data model ready. And of course, data virtualization is a data sharing and data hub as well. So it can onboard data and share the data to the consumers as well. Is like access to object itself, or giving them API to actually pull data from data virtualization. The platform helps you to actually work as a hub. At the same time, data virtualization actually looks after all the governance point of view of the data as well. You can automatically build your data dictionary. You can classify your data. You can apply security, tagging, and you have your own administration and monitoring. Everything is in data visualized environment. And so all these capabilities actually will be used by your visualization tool, your advanced analytic, or when you're actually sharing to third party as well. So that is the topic for data virtualization, and how data virtualization actually is the next generation of data platforms. So now, what now talking about the digital and content analytic use case, what was our use case which we actually went through the data virtualization journey? We work with a company which is here we call Company X, and Company X is like a portal developer. They develop e-commerce portals, but they do have their own customers, like 50 customers across the globe. And what the Company X does is it built some sort of templates based on the available technologies like omni-channels or augmented reality and different technology which are available these days as a web application development and e-commerce sort of a business. They develop those templates, and based on the templates, they build different web pages. And once they build the templates and the web pages based on the templates, they have some basic contents, but they go to the next cycle, which is the customization of these web pages. Customization means they change, of course, the logo, the URL itself, the background image, everything, but if they will actually change the content and they customize the content based on regional and global need for each of these customers as well. Then once actually they make it ready, development happens, customization is ready, and then they push it to operation. And each of these clients, they start to actually accept real business customers into their own e-commerce as well. And at the same time, the platform starts collecting metrics like the page clicks, the page navigation, who actually navigated which part of the page and how long they actually been looking at that specific section of the page, and this kind of metrics. And of course, there would be some portion of the revenue of this platform which come back to company X as well. So that is the deal with them. The more revenue the client gets, the percentage of, the percentage of course is the same, but the portion of the revenue for the company X would be higher as well. Company X and all the clients, 50 clients, they want to actually use content analytics to be able to analyze the page click and navigation clicks and the revenue with the actual content and the templates, and see how they can automatically change the contents based on the regional and global trends, and use AI to actually detect what kind of, for example, content is more interested for the people searches, or even when they're actually navigating, what content makes them more interested, and of course makes more clicks and more revenue as well. So they want to have a look back to the customization process to automatically generate the content based on the real interest on the market as well. So it's like a data ops. You put application into operation, you collect the data, and the data itself decides what has to be the next level of customization, and then it comes back to the operation as well. So yeah, the objective is to, of course, increase the revenue, get more page click, but do it automatically through using AI to generate better contents, and redirect company X and clients about the right template as well, which template is actually the current market trend and for example, regional requirement as well. That was the use case. We tried to help them to use advanced analytic and generate the content automatically as well. But before we go to the actual solution, we had some bigger strategies as well. Well, fast go-to insight was one of the main strategy for this business, because in the digital business, web technology keeps changing, and they want to make sure they can be fast enough to change the content based on the trends in the market, and be in the top of the trend, and of course get more revenue and clicks as well. So they needed a platform, analytic platform, to be actually generated fast, and of course be updated fast as well. So they couldn't tolerate long process of generating ETLs, different storage or staging interim databases to actually handle the ETLs. And they couldn't actually tolerate it, and they said, till we get all these long process happening, our requirement changes as well. The new web technology comes through, and the trends of the market changing, and we have to actually work fast. The second was the shared analytic workspace. They said, well, we work as a partner, company X and all the clients, and between the clients, you are actually a big family. So they want to make sure whatever trends happening in one region, another region actually can use it as well, or whatever pattern they discovered, they can share it across the whole ecosystem as well. So they wanted to have a workspace which is the workspace itself actually is shareable, and they can work together as a big family.
Mm-hmm.
Time and cost optimized platform. Well, they wanted to have a platform which can be very fast, and the cost is affordable as well. And ETL and a lot of staging environments are very expensive. And they found data virtualization is a technique actually will reduce a lot of cost, and of course it speed up the whole process as well. So that was another strategy was in our platform selection. And the last one is the low complexity. In advanced analytics, there is a big trend of the language or tooling across any organization as well. The TSQL and one of the advanced analytic scripting language like R, Python, less C Sharp with AI capability, but more R and Python with T-SQL is very, very common these days. There is a very big correlation which people actually going to this way. So T-SQL, it's a long history behind TSQL, and a lot of people actually are familiar with that one. So no actually big drama. And our Python actually, they introduced themselves very quickly as well. So we try to make sure the platform we choose has the low complexity, and a lot of people, data scientists, data analytics, analytic people, as well as the data management in data as well. They can understand the ecosystem and they can actually add value as well.
Right.
So with all these conversation around the data virtualization and the requirement for our use case and the strategy, we came to Lyftrondata as a real data virtualization platform. And we built the entire solution based on the Lyftrondata platform. But in this webinar, we have a smaller set of that use case which we have run with for our client. And I want to actually walk you through on that minimum set we actually implemented. So in this use case, which again is a subset of our big use case, we have a revenue which used to come in Azure Blob storage before 2019, but because the party which actually collect our revenue information, they changed the product, and now they're dropping data in the S3 bucket. They send a similar value into the S3 bucket after 2019. So to us, actually, data or revenue actually is distributed into Azure Blob Storage and the S3 bucket in the CSV format. We also have our web page content into Azure Blob storage as well. So it's like the whole HTML page, which we remove the HTML tags, of course, but the content are actually in the Blob storage as well. And we do have a MySQL database, which keeps our customer data, all these 50 customers, the basic information, what kind of the pages they used and they currently using, the latest version and the history versions as well, and the click information. What are the which kind of pages actually, how much click they get for each of these page. So all actually stored in the MySQL database.
And
So
how
as you
often would
see,
this usually be updated?
well, these payments are monthly. We get one file, or actually, we get one file each month, which has all the customers and the revenue actually received from the different customers. But the customer info doesn't change a lot because there's a basic profile of our 50 customer, unless we onboard another customer. But the page click info is real time. So the real customers, people actually navigating through different pages, and the page actually generates some metrics and drops metrics into the page click info. And web info, again, it's static. as far as the next cycle of web development doesn't happen, or the content generation doesn't happen, that data is static. But if the content generation happened and new content is proposed to a client, that data will be updated, and this table will be updated accordingly as well. So as we see here, our data is actually distributed in two different cloud environment and different technologies as well. But for us, they are just data. We call it data set, you call it object, or you call it data frame, doesn't matter, it's the data. And in the data virtualization topic, they are actually data. We call it assets, data assets. So we're trying to see all of them as a data asset, regardless of the technology, or we actually they are two. But in the right side, we do have a Snowflake as well. We actually, in the advanced analytic, we're not using Snowflake itself directly, but we do have another use case, which we're using a Snowflake as a cloud data warehouse. And as part of this use case, we're actually pushing some data to a Snowflake as well, which is related to another historical and a snapshot for the analytic. But for us, that is sort of another target. But the actual sources of data are, coming from this side as well. So to get to the solution, first we build some connection. We build connection to MySQL in the AWS RTS. We build some Blob storage connection to our web contents and CSV contents in the Azure Blob and S3 bucket as well. I just want to show you the actual data sets here. So I want to bring my whole data here. So this is my Azure, and I do have two containers here. And the first container is my the revenue container, which used to come from 2018. This is all the payments from the 2018. And the other container is my the web page contains is the customer ID, the actual template and the page name and the version as well. They are actually dropped in the Azure Blob storage as well. And in S3 bucket, I do have my payment, which is coming from 2019 as well. So as you see, there's one file per each month. And this is my MySQL database as well, which is in the Amazon RDS. And that is my Snowflake data warehouse, which I have here. So these are my environments. So I will start building some connection to my sources. And on top of that, I'll try to introduce some sources. In this case, we have a source, for example, called my payment 2018, my payment 2019, web pages, and all the customers as well. And in the other side, I do have my data warehouse connection as a target as well. After that, I start to build my virtualized environment. So I try to map these objects or blob or the files to an object or table or data frame is called web page. I'll try to convert that one to another table or data frame called 2018 payment, 2019 payment, and customer info, web info, and customer billing info as well. As you see here, this is all my virtual environment. And I can also add some tags. It's financial, for example, value there, financial value there. Here I have my personal identifiable information there as well. And also I can mask some fields, which, for example, I have the credit card information here, and I want to mask my credit card as well. Before doing anything, I can build another level of virtualization, which I can combine these two as another data frame or table. It's called all payments. And also I can add extra field into my customer info, and I want to add virtual column called region, because I don't have a region, for example, in my customer info table. So I can add virtual column as we go as well. So I added another layer of visualization. And on top of that, I want to build my final, one of the, for example, final outcome, which is called APAC customer info. And that is another virtual object or virtual data frame. And so far, we built some virtualized tables, objects here as well. And the beauty is you can start using Power BI, Excel, whatever AI or visualization tool, and start to use these objects. We want won't be doing it here because we have another step, which is the more advanced sort of a visualization, but the capability is still available here. So next step, we can, from this visual object, we can directly populate our some dimension tables in our final Snowflake data warehouse as well, which we can build, for example, dim customer, dim template, dim website. These are, again, objects in memory, or they are data frames, but the data frames at the same time can be mapped to physical table as well to be like a real pipeline. And as you see here, we haven't done any ETL. It's all in the platform, and you go through the platform and you build all these virtual objects and you map them into final environment, and then you can push this data to the final storage as well.
So that's all in
But
Lyftrondata.
all in the Lyftrondata without any ETL job at all. Okay,
Wow.
it's all visualization.
Mm-hmm.
We can do for the rest of the, for example, tables like pack payments, click, and customer statistic, but it would be a little bit slow, and the slowness is mostly because of the nature of this connectivity provided by these providers, and that is why we're not recommending to do it from here. Now we're going to the next level of visualization, but make the ultimate performance, and that is by introducing Lyftrondata Lake, which is based on the Spark technology. But it's sitting on, again, visualized environment. And for building that one, I start to actually bringing all these virtual objects into my Spark as a second level of virtual object. And again, I can bring it from a Snowflake as well. I can have visualize the object in my Lyftrondata Lake. I can rename them. I can put them into different schema. I can do whatever I want. So for now, some of these virtual objects been dropped into Lyftrondata Lake. These basic fact tables actually came through in the data lake as well. In data lake, I can apply a second level of visualization, and I can build a more sort of virtual object, which, for example, I can combine all of few of them, and I can build virtual fact payments, virtual fact clicks as well, and I can build some features which can be used for my machine learning as well. So these are some virtual object on top of existing virtual object coming from the lower sort of visualization as well. And again, I do have all the capability to apply further tags and all the what is called the data governance as well. But as an example, I want to share one of these objects to my third party. In this case, is my personal email address, but it could be anyone. That person, if he's not, for example, linked to Azure AD, which is available in the Lyftrondata, it can be introduced as a user into Lyftrondata, and then you can share the whole connection, the source, or a specific object to a customer or one user as well. And in this case, I want to share one of these objects to myself as well. And on top of that, I can start using Power BI, Excel, whatever visualization and advanced analytic on my second level of visualization, which has ultimate performance because everything is cached in memory with different Spark technologies, in fact.
Okay.
After that, I can start building my AI using, for example, in this case, Collab technology, the Microsoft Collab use case, and I can apply some machine learning on top of virtualized object. And I can remove some outliers on my data by Z-score technology. I can see regression data. I can apply some time series. I can see correlation between my revenue and my clicks, and I can do some text analytics as well. After that, I can get the insight, very advanced analytic insight, back to my visualized environment as well. And finally, I can use my virtual environment to populate my Snowflake, which can be used for future use cases or integration as well. So as you see here, we build all of this stuff without actually ETL, and all is visualized. And as you build, automatically you get a data dictionary. All the objects are available as a hub feature, and you apply classification as you go as well. And if you want to build all this scenario, you probably need 2 to 4 hours to build entire ecosystem. But for now, I built all of them myself. So I can walk you through what we have done, and we can go to the machine learning as well. But after the break, you can come back and we can build this platform from scratch to see how easy is that. But as I said, it takes 2 to 4 hours to build. So we do in 20 minutes what we can do. So let's back to real environment now. So this is a let's bring the okay. So here I built that environment, this use case in Lyftron. You can see the name is starting with the APAC customer, which is actually representing the APAC customers here. APAC FS data mode, which is that FS data mode, the Snowflake. We do have the AWS payment, that is my AWS payment, and we do have Azure Web Pages, that is my Web Pages, and we do have Azure payments, which is that one as well. So these are my sources, and of course, I do have my Spark data lake. This is my Spark data lake, and I do have a Snowflake as my target as well. A Snowflake is my source as well as my target as well. So if you look at my data lake here, you see I have two schema. You can generate the schema as you go. So you have this opportunity to build as much as a schema you want. And in the Lyftrondata schema, I do have these objects, customer info, page info, and all the objects you see here. I have them already here. In the feature, I do have top level objects into the feature schema as well. So let's start from the basic, which is my source. I want to, for example, show you my Azure payments. This is my Azure payment. And Azure payment, you see, I have just one table called payment 2018. But if you notice, I actually have my Azure payment into individual pages. Okay, it's not just actually one table. In Lyftron, you can combine all of these basic CSV files into one table. And that is how actually you get all these data combined as one table as well. So you can easily query it as well. So as you see, I can query my payment 2018, which means I actually, in this my virtual environment, I generated that virtual object, and I'm querying my Blob storage directly as well. And it's actually a little bit slow because of two reasons. As I said, well, that is a trial environment, and the backend provider from all of these cloud environments are by native slow as well. But you see, my data actually being queried from all these CSV files, but combined to one giant table. Similarly, I see in the AWS, I have just one table. It's called my payment 2019. But as I mentioned, I can build a view which called all payments, and I dropped it into another schema which I built called my finance schema, and I generated a view, and this view actually is a combine of my Azure and my S3 bucket CSV files as well. And I can query this one as well, no drama. You can have another query, and you can query this one. This is one of the most capable feature in the Lyftrondata, which is you can query cross-domain sources. There is no way to actually easily query this CSV and this CSV in one SQL, but in Lyftron, you can join this table, for example, from my AWS to my Azure easily. That's no drama. You can easily query them, which actually we put them into that view, which I can bring another connection, and I can show you the query behind that one as well. So it's in the AWS payments.
Do you need to know the primary keys in order to just join those, or does
Up,
it have some
up.
sort of an automation?
Sure, no, no, no. In Lyftron, once I can as we go. This is my AWS payment, and when I have, for example, my basic table, which is this one, I can apply virtual data modeling as well.
Mm.
I can define my primary key, foreign key, everything as well.
Oh,
So
wow.
this is the full visualization. So you can map your files or tables, whatever, to visual objects, and then you can actually play with data modelings with all the data modeling context as well. And this is my view, which, as you see here, this view actually is uh, it's a view of payments, and just coming.
Yeah, this is fantastic that you can do all this stuff really virtually.
Yes, yeah. View of payments.
Well, this is how we know it's a live show. Things
Yeah,
happen
it's coming. It's
sometimes.
coming. These are it's all payments, and I've been able to query, which it includes my Azure and as well as my AWS as well. As you see, that is actually it comes is a little bit sometimes slow the platform. This is my query. As you
Mhm.
see here, I do query my Azure payments directly with my another one is select from my AWS payments. So this is a union all
Mhm.
of my data from uh, um, uh, AWS payment and Azure as well. So cross-domain query is absolutely available here, and that is a magic, and you can even do it here. So similarly, data for the customers, we put all the basic customer objects tables into say, customer schema. And on top of that, I believe we do not have any view, but in the customer info, you see I added the region as well. So I want to show you custom field, which I added in one of these tables as well. So this is my virtual table. And in my virtual table, which is mapped to my MySQL database, I added my region as well, which is calculated. And you see, this is the calculated or virtual logic for that calculation as well. But at the end of the day, it's simply it's a field as well. And I can, if I come here, I can easily query my table, and nothing fancy. Region is another column as well. And you see my region here, it's shown as America, Asia Pacific as well. So virtual column is available here as well. And what else? So we saw actually the connections and the sources and the objects here, and we saw how we actually view payments applied here. More topics here is about some tagging and masking. Credit card, for example, is one of the secure sensitive information, and I can actually apply some masking. So I can hash this column, so make sure the credit card always is hashed. And if you look at the query which we have here, yeah, that here, okay, that is the credit card,
Mhm.
uh, email address and credit card. See, is just been is hashed as well. So
Yeah.
our credit card is automatically hashed. So, and the tagging, any source, any source itself, or any table or any object here, you can apply some tagging. And here, for example, I do not have tag on the table level. Maybe I have tag on the column level, for example. If I go to, for example, the name, I can see whether I have tagging or not. Yeah, I do have the PII, for example, or I can add more taggings as well. So if you're admin, you have the tagging capability and classification, and you can apply more classes here as well. But for example, we have PII, PHI, and finance as well. So you can apply, you can classify your data, whether it's the full object, the connection itself, or the column level, and you can apply some masking on the individual columns as well. So let's go to the next topic. We already actually 40 minutes. So let's go to the data lake. We explore a little bit of data lake. Uh, this is a Spark, and compared to what actually objects we have in the first level connections, we do replicate these objects, and we can actually apply some magic in Spark or Lyftrondata Lake, which we call it first we generate some pipeline. This pipeline actually is not ETL, it's a pipe to the source to an object, a data set or a data frame. But as I said, that can be actually mapped to physical object as ETL if required as well. But for example, this object, this pipeline, uh, we do have we actually brought it from lower environment. AWS customers is mapped to this customer SPK customer info actually maps to this customer info from lower environment, but you do have some magics here. You can start pushing some. You can ask to cache this object in memory and schedule it, and this object will be actually another virtual object in the data lake, but it has the built-in cache. And that is why when you're querying for example the same table here in Spark, it's super fast. It's super fast because these objects are in memory now, and still they are virtual object, and you can build object on top of object. You have data modeling, classification, masking, everything, but they are actually managed by Lyftrondata Lake to be cached and give you the ultimate performance. And still they are like data frame tables, and you can use Power BI, AI, whatever, to connect to them as well, which we'll actually show them in a second. So that's the beauty. And as I said, on top of this object, you can build a second level of visualization as well, which you see here. For example, my customer, some payments coming from my lower environment, lower object, virtual objects as well. So for now, it's fine. I want to show how we can actually share to one of these customers. So that says view APAC customer info. If I go to my, if I go to my target and use my Lyftrondata Lake, go to my pipeline is LDSPK. So LDSPK APAC customer info. Most probably I have already access right. One access right here, which I given access to my personal account, and this is the select permission. So if I go to Lyftron this time with my personal account, I must probably be able to see that object. I should be able to see first this data lake, because this is the same data lake which my main account, my master Intelicosmos actually is building as a owner, but it's shared to my personal account, and I logged in my personal account as well. So I see that account, but inside that one, I see only one pipeline.
Mm-hmm.
This is only pipeline which I share to this guy. According to this scenario, I just share this object to this person. And yeah, I can see this object, and I can actually see the data as well, super fast. Yeah.
So easy.
So easy, and you have proper administration and security, everything as well. So this is what actually customer X can actually share the analytics and all the visual objects to its own clients, and vice versa as well. So this is the next level. Let's go to the Power BI and see how we can actually connect to Power BI. I'm not going to build any Power BI report, even I have. I want to show you how actually we can connect to this virtual environment, especially the Spark environment.
That'd be
Let's
great.
open. Yeah, let's open Power BI desktop. Uh, I'm running out of time. The topics are interesting.
It's okay. It's
So,
okay if we go a little bit over as well.
sure.
No worries.
So I'm trying to open my uh, Power BI. So this is my another screen. It's a little bit slow. So let's bring it here. This is the Power BI desktop, and I can go to get data, and simple. I can actually get this data, do a query, and I can do uh, where it goes. Yeah, you see it's connected, and I
Hmm.
see my data lake. Not only data lake, I see all objects which I see here. If I go to analyze, oh, this is my personal account. Let's remove this one. If I go to analyze, these are all the virtual environment I have, and they are all available in the Power BI as well. And I can choose whatever I want. Yeah, it's all available in the similar way. Actually, Power BI can connect to anything, but now it's connecting to this virtual environment.
Hmm.
So I don't want to build any report. It's simple. You drag it, drop it, and you build. You know better than me. You can build perfect reports, but that is simple as it is. It's similar to connecting to SQL Server, which is like a wrapper in Lyftron environment, but actually it's connected to all the backend logical environment as well. And similar way, of course, you can do the Excel as well. It's the same plugin. You can use it, but now I want to actually use the time and go to the machine learning, which is more interesting as well. If I go to the visualize, I see I already actually have a Colab here, and if I click the Colab, which is my machine learning platform, I can connect to one of the notebook actually which I generated for this purpose, and uh, I do have some uh, machine learning job actually is running here. And of course, it's not the full example of what we have done for company X. It's just to explain how we can actually connect to Lyftrondata and apply some machine learning and get the data back to Lyftron as well, and and actually benefit from the result in the visual environment as well. So for that purpose, I have to show you one thing, which is uh, I don't want to actually share my detail which I'm actually connecting, but I'm using PyODBC.
Hmm.
I'm using PyODBC, and I'm connecting to the Lyftron server with my own account. You don't need to have separate account, and using the user password as well. So I build my connection string based on that one, and so in the preparation, I just get something installed, which I have to run it because it takes a little bit time. I get some libraries installed. I import some libraries, and of course, I build my connection string, which actually I showed it here, but I want to actually open it here because of the shared password. So we till actually is running. It maybe takes 30 seconds is the first time, but you can upload all these libraries to make sure you're not running every time. So let's back to some other topics which we can help us here. As I said, as we building all these objects, your dictionary actually is available as well. So if you go to the catalog, you see you building the catalog data dictionary automatically. You're not even noticing something actually happening in the backend as well. So if I search for my credit card, I can see where actually credit card exists,
Well.
and it has the finance tag and it has the PII tag as well. And it's, for example, here is it the type of that one. So you get the full dictionary. You can say, okay, I want to see everything which has, for example, PII data. These are all the places you have PII data. So the data dictionary gets built automatically as part of the virtual environment. Second thing is the hub. As you saw here, I've been able to share one of these objects to one of my personal account. Of course, you can share the entire ecosystem to another person or customize it as well. But you do have another beauty here as well, which is the API. So if we look at the Lyftron the environment, you do have the Lyftron API capability, which you can access all these virtual objects through APIs as well. You can look at the tables or pipelines with APIs in the real time as well. So this is another capability which you can use this virtual environment as a data hub, and you can hook your system to integrate with data hub as well. And next topic here is let's see, next topic. Okay, I mean the basic topic, we went through that one. Hopefully that's finished. So here I have a query which I'm connecting to Lyftron environment. You see that is exactly my data lake pointing to my feature schema, and this is my actually object, which I have it here. This is one of my object is customer sum payment, customer sum payments. That one, for example, is my virtual object. And another query is my same data lake. It is the monthly payment. So you see I'm running the query, and it's super fast. It's showing some of the data. It doesn't show all of them, but it's super fast. Then I do have another two queries from the same data lake. It's pointing to another two objects, virtual object which I have, which is about the customer clip. And again, that is super fast as well. So again, as you see here, it doesn't show all of the data, but it actually fast coming from my data lake as well. Then I go to my revenue analysis. In revenue analysis, as I mentioned, I want to actually apply some outlier. I mean, I want to remove some outliers by Z-score. I imported the libraries, and I can run Z-score on my revenue data frame, which I built from the higher queries, and I can actually run it, and I can see I removed my outliers, and I draw some regression lines as well. So I put some regression algorithm here, and it actually generates some regression lines for me as well. So this is the distribution of my revenue, and this is my regression line after I remove my outliers. The next step is time series prediction. So I want to actually understand how my revenue actually looks like now, and what is the prediction on the revenue. So I use the RMA, and I imported libraries, and I'm running on revenue the data frame. And this is information about my model, which I built. I built a model based on my revenue data frame. And this is the residual and density of my revenue, and that is the forecast versus actual revenue as well. And then we go to the text analytics. So let me close all of them. And so far, we went through actually removing outliers, applying some regression algorithm, applying time series, and now we do actually seeking for correlation and some text analytics as well. So before we go into the text analytic, I generated a function. In the function, which is common functions in natural language, is I actually tokenizing my, okay, I'm applying all these NLK or text analytic based on my content, which is available in my web pages as a separate files, but combined to as a web page object as well. So I try to actually understand what are the common words available in my web content, and what is the correlation between revenue and page click associated to each of these web page, and then I can understand what keywords actually are generating more correlation, more revenue as well. So before going to that one, I have to build a function. So I'm actually tokenizing my word available in web contents. I imported the stop words to remove a lot of stop words, but still I have to add more stop words, manually remove them myself as well because this stop word is not completed. Then I do apply some steaming to make sure all the words actually are steamed and they come to the basic form of the word as well. And finally, I generate some form frequency distribution as well. All goes to one function, which I put my text and I get my frequency as well. So my function actually is ready now. So now I go to my text analytic. First of all, I want to understand what are the correlation for each of these customer, what is the correlation between revenue and the page click. So I apply the first section, and as you see here, I have a few customers. The first customer has 60% correlation between revenue and the click. The next one actually is negative. The more click, the less revenue. And the last three customers, they don't have any correlation at all. That's fine. Then I try to actually load my content, which is coming from my data lake, but actually is from coming web pages, which is mapped to this virtual object, which is mapped to my web page content as well, without any ETL, of course. So I'm querying from our data lake, and I get my HTML content, and I'm trying to actually build a dictionary for each of the customers. I want to actually build a list of words as well. So I do have a dictionary list of customers and all the words available in the web page as well. Of course, it goes down to different template and different pages and different versions as well. So for each of them, I have actually separate list of the words as well. And the next section, I try to actually generate my frequency distribution and link it back to my first collection, which was my customer ID and my correlation between revenue and page click. And I want to understand what are the top five words in my each customers as well. So I do run this part, and as you see here, this is the best customer in terms of frequency distribution and the page click. This is the highest page click we had, and these are the five best words we have in our page clicks as well. But we already populated the best five words for each individual customer individual as well. So we populated this one as well. And the last section, I want to actually bring this data back to my data mart as well. So I will actually get my customer statistic data frame back to my ecosystem. So as you see, it's saying insert completed. So I took the data back to my this object, which is available in my ecosystem as well. So I want to query that one and show you where actually that data sits. So if I go to my Snowflake environment, which I have my Parker statistic object, if I query that one, I see the same value here. It's saying the second customer has the best correlation. This is the five best words and blah, blah. So what does mean that mean is I actually build these virtual objects and I generated some machine learning, and the last data frame which I was interested and return it back to my ecosystem, and I can use it in the Power BI or whatever else as well, or I can share it to entire ecosystem or other customers as well. So this is the full picture. And it's almost 1 hour, so I want to actually stop here, give some time to people get some break or ask some question, and then if people are interested, I'm happy to actually spend another 20 minutes and try to replicate this environment from scratch and see how easy they are.
Thank you so much, Ali. Yeah, there are a couple of questions. I was wondering, first of all, the speed of the queries that you're showing there. What are they dependent on? Are they dependent on that Azure environment, on the AWS environment?
By nature, regardless of what platform we're using, these plugins or connectivity SDKs, whatever REST API, whatever connectivity is available to connect to these sources is out of our actually access. This is provided by the cloud providers. If they have a high SLA, we get better SLA as well. But definitely, those SDKs and APIs are slow. The slowness come from first here, but there is a second slowness which is related to the platform actually we're using, because everything is on the fly. It gets a little bit slow. So the advanced analytic platform, which is coming as a SaaS or PaaS offering, must be provisioned properly to give you better performance as well. Of course, we're using Lyftron trial environment, which has a lot of people actually working in that one, and it has limited in the scope as well. But if you have a better scope, you get better performance as well. But to get ultimate capability, we always recommend to actually get the data lake capability and map these objects directly or indirectly from intermediate to the data lake to get the ultimate speed. Again, the data lake we're using here, which is based on the Spark technology, is very limited Spark context, but you can attach it to, for example, Azure HDN side, which you can leverage very big cluster, and you can get much faster than what actually we saw here.
All right, thank you so much, Ali.
No
And
worries.
Pragya here is mentioning, a very insightful session. Thank you so much for sharing.
Thank you.
And Carol McGrath, who's joining us from New Zealand, is saying that very interesting to see Lyftron data in practice. Interesting diagram of the pipeline as well. This one that you're showing right now, Ali. Is it something that can be shared? And I mentioned
Yeah,
that, well,
absolutely.
this will be a recording, but to reach out to you as well, and I'm sure you will be able to.
Absolutely. I'm more than happy to share the PDF version of that one. We can talk offline to see what is the best place to actually share it. But the PDF format of that one, absolutely, more than happy
Oh,
to
that's
share it.
wrong. Thank you so much, Ali. So there you go, Carol. Just follow Ali here on LinkedIn, get in touch with him, and he'll be happy to share that with you.
Sure.
Thank you. And yeah, we have some really great comments in here from Angri and Esan. Nice presentation, Ali. Loved it. And
Thank
Matt,
you.
Madia, great intro, Ali. So,
Thank you.
and one last question here on when you showed the hashed credit card data there, does then Lyftron data also detect that sensitive data and
It
transfers it
doesn't
into a
have
hash?
it doesn't have the auto detect of uh, sensitive
Yeah, but you
fields,
can
but
flag it. You can
something.
flag it at
I,
column
yeah,
level.
of course. As a data governance process, you have this capability, and you can go to tagging and classification of your field, and including masking as well.
Hmm.
But it is not automated. But I believe that is something Lyftron actually, as a feedback, can get it and add it as well. It's not hard. It's just based on the collection which they can actually put and recommend it as
Right.
well.
Right. And that ties into another question from Carol here is, does data governance, data quality, and lineage of metadata come into this pipeline at all? Or is kind of obfuscated from this layer?
It's all built in the Lyftron. I'm not doing any ETL. I'm not building the data dictionary, except as a data owner and a steward, I have to actually apply some classification or tagging as well. But the rest is actually automated. So all the lineage happens automatically, and because everything is virtual, we're building objects on top of each object. It
Hmm.
actually generates all the dictionary and lineage as well. So nothing actually I have to be worry about it.
That's wonderful, Ali. Thank you so much. And why don't we go into the demo now and see hands-on 20 minutes on a quick build?
Shall we get 10 minutes break for people and then come back, or I have to continue?
No, I think we can. Yeah, just go through it if you're okay
Sure.
with that. Yeah.
Yeah, absolutely, my pleasure. So, as I said, it takes approximately 2 to 4 hours to build this ecosystem. But in 20 minutes, I try to actually replicate the most important part of that one, and but it should be pretty similar to what actually I'm doing here. So let's start. Okay, what actually we have here? Let's go to back to my environment. What we have as an APAC, I'm going to actually build a copy of that one called copy APAC. to make sure we're not actually getting confused. So let's get rid of all these objects. So I want to start building first thing connection. I want to add connection. I choose. There are 300 data sources, very important data sources. Kafka, a lot of things are there. So you can actually look at the Lyftron, and you will see it has a big list of actually data providers. I want to actually look at the CSV. So I go for CSV. I provide this name. That is my URL. As you see here, I'm adding a tag called aggregate files, and that is how Lyftron can automatically combine all the CSV files into one file, and that is the magic in the Lyftron. So no actually drama, you build as you go, and you get the table or CSV actually merged together as a one file as well. And this is my Azure Blob FS container. It's a CSV format. I give it a test, and it's just created. So I go to the next one. I'll build my web page one. Maybe I can actually leverage parallelizing my environment. So as that actually building, I can go to another connect, and I can add another connection. I can't choose the text file, but my web page are actually in form of CSV as well. We have just one column called the content, and I want to actually leverage CSV as well, but you can use text as well. Again, I want to combine all my web pages into one giant table as well. And this is my my connection, which is coming from the website HTML. I combine them, I test the connection. That's what is called contains name is already exist. Okay, maybe build, copy what yes, that is my Azure payments. It's built. That's built as well. This is my Azure web page payment. Now I go to my AWS payment. So I build this connection. I build this one. I'm going to build the other one. So I'm going here again. I'm adding another connection, which is again CSV. I do build this one, which is my AWS S3 bucket. Again, is a CSV. Again, combining all of them as a file. It's dropped into my Sydney region as well, and it's actually in my S3 bucket here. It's a CSV test connection. Yes, build. Now I'm heading to build my MySQL connection. So let's go to that's been built because I'm using 3 of them. So Azure, APAC copy, AWS, Azure web pages as well. So let's build another connection, which called MySQL. And this is MySQL. These are, yes, sorry. This is my MySQL connection name. This is the IP I'm using. This is root user, and that's the firewalls. You just need to add something here to say the blog, which is internally used, but it's not really important. So I built a connection, but I do have multiple schemas, and it's asking me what is the default schema, which is customer is my default schema as well. And then create. So I built this connection as well. So now I'm going to actually build data sources as well. So my APAC copy objects are there. So I'm going to the source. I'm building another source, and the sources are much easier. This is from my source is AWS. The first one is Azure payments. This is my Azure payment. I want to give it a name. You see here, it understood all those individual CSV file and put them into one called aggregated files, but we will rename it because everything is virtual. We will rename it later to payment 2018 as well. I want to actually rename that virtual name to that one as well. So where is my Azure copy payment? Yeah, this is my copy. This is my virtual object, but you're able actually to rename it as well. I can't give it payment 2018. Simple. And of course, you can share it. You can apply some classification. Everything is available as well. So my object now is turned back to 2018. So I do the same for AWS as well. First of all, web pages. Let's go to building a source called web pages. This is my Azure web pages. This is my name. Next, it would be same aggregated name with a built-in CSV schema, but I show you how to generate a new schema for your own need as well. That is how you generating data model virtually as well. You don't need to stick to one schema, one table name, blah, blah. You can build everything virtually as well. So did I click? So I'm building this web page as well. So as you know, it's actually showing me as an aggregated file, but I need to rename it to web pages. So where I am, it's here. I want to edit it, give it web pages, and yeah, I built it. But I want to actually do one more thing as well. I want to build this object right now. I want to combine my two. Oh, I didn't build this one. Let's build. Okay, sure. My web page, I missed something. I have another object on top of that one.
Mm-hmm.
I want to actually build that object as well. So that's been saved. Okay. So I can build a virtual view and I can choose, I want to drop in the DView this time. This is called view web pages. It's a SQL query. And my SQL query simply is this one. I can parse it and I can create it. So actually this year I'm missing one more object, which is here. So let's back to build my AWS payments. So as we're building here, I can go to my sources, add another source, get from my AWS payments. This is my AWS payments. And it will actually generate, combine all my 2019 after as a one giant file, which I will rename it same as the other one as well. So I'm actually building this object now. So my view is built as well here. So on top of this virtual object, I built another virtual object now. And if I go to my AWS, yes, that one, I do have this table. I want to rename it, same as the other guys. I want to call it 2019. And we are here now, and I want to build this virtual object. But before going to build that one, I want to actually drop it into my finance schema. So I want to build a finance schema first. I do have a CSV which been built in automatically, but I want to generate my finance schema, and I called it finance. This is my finance schema, and I want to drop this virtual object by combining these two into my new schema as well. So I go here, and that, as I said, cross-domain queries available. So no ETL, nothing. We build visual object on this one, virtual object on this one, but we're building combined query, cross-domain query already as well. So I choose my finance one. This is my view all payments. I have to get the query. Yes, it's a SQL query. You do have other beauty as well, which are out of its context. You
Mm-hmm.
have a lot of other options, but we just got the custom query. So the query is fine and done. we build another virtual object. Is this virtual object? Let's build one of these tagging as well. We just missed adding tagging, but it's pretty similar. We don't need to actually do everything here. So let's go to source. I want to, for example, payment 18. I want to add some tag. So my payment, for example, this guy, this is a table. And I can apply on the whole table, or actually I can go to column level and say, in reality, my payment actually is just PII, or sorry, finance data. So I can choose my finance and I can assign it, and it assign classification on just the column level. So the column level classification is applied. Did I choose PII as well? Partner business name PII. Don't know what does that mean. I just choose the PI finance. I don't know what is coming here, but it just apply the finance. But you can apply on, as I said, connection level, source level, object level, column level as well. So let's see what is this object. Yeah, my this view payment is ready. Can I see the data here? Of course you can see the data, and it shows the data on the fly on top of Azure, Blob, and S3 bucket as well, without a single data shuffling, data movement as well. It's a little bit as slow as we said, because it's querying two different cloud providers as well, but it will bring the data. But we move on to the next step. Next step is to bring all these customers as well. So let's go to my new source, which I want to build here. I want to use my AWS customers, which is my SQL. This is my customer. It understood customer schema, because we said this is my default schema and these are the table there, and I can actually bring this table. That doesn't mean I build the tables. I build the metadata of the tables and I assign them to a virtual object here. So nothing in terms of the data itself. And this is the copy APAC AWS customers as well. And these are the tables as well. So I want to add the visual column here. Oh, before going to that level, let's go to the column and apply some hashing as well, okay, or masking. It doesn't need to be always hashing. I go to credit card and I go to edit, and I'm saying, hey, this guy actually, I want to hash it to make sure it's actually not circulating with the real credit card number. It's just hashed, okay? So this is the masking which I have done, and I can apply different taggings as well. I don't want to repeat that one, but I want to actually build custom field as well, which is the region, okay? So back to my columns, I can add virtual column. I give it a name, region, and this is my statement. I can say, hey, this is my statement, and please build this virtual column on top of my existing virtual columns or table as well. It's coming here, and I can say, hi, this is a summary, customer info. Can I see the data? Yes, you can see the data. Do I get the region column? Yeah, you should be able to see the region as well. So the virtual column is already added automatically. Credit card is masked automatically as well. So that's the beauty of governance and virtualization altogether. So we can build that one as well. I want to actually skip this one, just taking time is similar. I want to actually move on to the next step, which is a data lake. Okay, so data lake actually here is in terms of targets. So I build the targets and I go to my targets. This is my targets. Okay. To be able this target or data lake, Lyftrondata lake, you need actually a Spark context. And that means you need to actually set up a Spark cluster in your on-prem Lyftron environment or your pass offering, or you can just configure it to link it to Spark context, which is available somewhere else, which could be, for example, Azure HT Inside or somewhere else. But in uh, Lyftron environment, there is already a connection. I'm actually not building the connection itself. The connection is already available called local Spark 2.3, and I want to actually build the source on top of that one to make sure my one is separate with the other one as well. Again, I'm using the same virtual context, but I want to totally segregate my data lake with the other data lakes which are using the same Spark context as well. So I built my Spark copy APAC Spark schema as well, and nothing is done. Here is the beauty. I can actually migrate all these visual objects into data lake as well. So I get the migrate data. I choose my data sources. For example, I see my copy APAC customers which I built recently, and I can actually onboard all of these guys as well. So we need to be a little bit cautious here, because I want to actually build based on new schema called LD. I want to actually give that one LD, and I want to rename to make sure is it start with the SPK underline, SPK underline dash, to make sure it actually tells me it belongs to actually my data lake environment as well, and then I get them imported. So I'm actually importing these three objects, including my custom region, automatically into a Spark as well. I can repeat this one for all other things which we built already as well. So let's get these imported, and then we go to import whatever else we actually built here as well. It, it's slow, just not because of anything. It's just because of the Lyftron trial environment. For the purpose of all the API communication is a little bit slow, but it doesn't actually do anything fancy yet. So if you have your own pass offering, or you do have on-prem installation of that one, you would be definitely good to go. But all the way we said, to get ultimate performance, not the same performance is here. We do have we want to actually leverage Spark capabilities, including caching as well. So I want to actually show you how we can cache one of these objects. I'll just forget to remove that one. No drama. I actually get edited as well. I don't know why actually I didn't. I remove that one. Meanwhile, it's saving. What I've done. Sorry. Where I am. Meanwhile, that works. I can refresh my page, and I can go to adding. This is the pipeline I want to change. Go to edit, remove the pipeline. Next, parse it, save. So I go to onboard the rest of the object as well. So I back to my my target, which is my new build data lake. Go to pipeline, go to migrate, go to migrate. It's been already updated, this is here. Go to migrate, and I want to use my, for example, AWS payment. I shouldn't actually need to bring this one because it's already coming as a view. So I really don't care to bring that one, but I want to bring my all payments here. So I want to remove that one, give it a SPK underline, and I want to call it LD because I want to drop it into one schema. So I shouldn't need to actually bring this base object as well because they are actually mapped to that one. So good. I'll import that one, but I want to show you how we can actually make this one super fast. So
Okay.
let's go to the customer info. I This is the pipeline. It's not the ETL pipeline. Is the object, data frame, data table, data set, whatever, which is pinged to my source. And I can actually get the replication, and I can say, hey, I want to actually cache it. Uh, I want to cache it into a Spark. In memory caching, you have multiple options. You can persist it on the fly as well. But I want to have a in memory caching. You can choose the partitioning. I want to choose, for example, 2 partitions, but you can leave it as a without partition. These are all the architecture point of view, but you can simply do in-memory caching without random caching as well. No actually big drama. So I actually set up that one. Now I go to management task, and I'm saying on per schedule or just ad hoc, please bring the data in my Spark or cache it in my Spark as well. So I'm actually fetching from here to my data lake virtual object to make sure I can play with my machine learning, Power BI, whatever, with my virtual object here as well. And if I want to actually bring the full set or delta, whatever, there is a schedule which you can actually bring in as a batch or incremental as well. So is it successful now? Okay, so I can go to show data, and this is super fast. This is super fast. So I'm actually querying from customer info, which has my region data, my credit card is masked, and all actually coming from my SQL as well. So because we build my payment as well, let me to do the same as well here and see after we build as caching, how fast this query actually is. So we see the performance and the benefits of Lyftrondata Lake for the purpose of advanced analytics as well. Let's go for 2. And I repeat that one. The meanwhile, I want to actually do the sharing as well. So let's build that object. So I need to build the APAC customer info. Let me find the query for that one. APAC customer info. Okay. So I go to my target, this target, build a pipeline, create a pipeline. I want to drop it into my the schema D, and I want to put this query. Hopefully this query, everything is fine. Now, because it's saying you don't have view copy. Okay, remember we didn't build that one.
Mm-hmm.
So let's actually share on top of this one, okay, instead of this one. Otherwise, we need to build that one as well.
Sounds good.
So yeah, I try to actually show you the uh, mm, sharing capability, not to actually replicating them as well. So before that one, I believe view all payments. Oh no, why actually we have this object we're sharing from here as well. So let's see. Let's see the replication is there, and I want to actually cache it in my Spark as well. So let's get it cached. So we actually configured that one as well, and we trying to actually bring it into the cache. Just the communication with Lyftron sometime is just started. In few seconds is going to be cached, and of course you can schedule it for future as well.
Mm-hmm.
And then I want to show you the performance here as well. And then I want to, at the same time, I want to actually go to the access right. I want to select my user. I want to select this guy. These are some mandatory stuff. You need to choose all of these guys, but give it a select permission, and I can save it as well. So let's go to trial with my personal address. And let's go to target. So I have 2. That was which one actually we previously shared, and that one is the new one as well. So let's see what we get here. Yeah, we do get all payments which we built a few seconds ago. Is that successful? Can I see data? Maybe it hasn't finished yet. Is it started? Okay, it hasn't finished yet. So I see the object in my personal account. I see this object, and I want to see the data as soon as this guy completed. Okay, so let's see this guy to actually cache into a Spark, and we can go to next step as well. So we build a few objects, and we can actually do the same as well. We can build let's build a connection to a Snowflake as a source. Where is my, okay, my Snowflake actually, because Snowflake is a cloud virtual data warehouse, and it needs compute, which you can use in GCP, Azure, or AWS as well. My one actually is dropped into AWS, and that is my Snowflake instance, which I do have some objects, and I can see there are some data as well. And this is my Snowflake instance, and I want to build a connection for Snowflake as well. That's successful. Okay, let's see the performance here first. This performance is for the owner. Let's get a refresh. It's definitely fast sometimes. Let's go to view payment, show data. Yeah, super fast. And similarly for the other, okay, that was my personal account. So I go to the second one, see the pipeline, which I generated, show data, and super fast as well. So same experience for the owner as well as the person actually I shared. I didn't share this object. Instead I shared this object for for this purpose. And I want to build the connection to a Snowflake as I promised. So this is my connection. Okay, I'll have to build Snowflake. Yeah. So let's back to my connection area. Add a connection. I'm actually building this connection. This is because, okay, as I said, it can be source and target as well. I want to actually build Snowflake as a source for now. So I'm using Snowflake provider. This is my Snowflake name, my account. This is my account. This is my, I have to choose my Snowflake as an order, is my Australia. This is the user I'm using. That is password. And this is my data mart, and this is my schema as well. So let's see. Yeah, I connected to my Snowflake, and
Perfect.
this is my Snowflake database catalog, and I generated my Snowflake as well. At the same time, I can build a Snowflake as a in target as well. So similar approach, not really big challenge. I can come here, I can say, okay, this time I can choose a Snowflake as a target, and I choose that one. My copy, almost similar account. Other, everything similar, but I don't want to build it because I already have my, this is my personal, oh, did I build in my personal account? Oh yeah. Which one we built for new a copy? Oh, it's here. Da, da, da. I think we built in the source. Okay, let's refresh. So we build the Snowflake as a source. So if I go to the source, I should be able to see the copy. AWS, go down. AWS copy AWS. What's happened? So maybe I actually built into another environment, another account. So let's search for this one. Now it's not here. So I think I built that in my the other account which I was there. Uh, Not a problem. So I do have my Snowflake AWS, the main one, which actually I use for demo. The one actually I built was just copy APAC. Everything is similar. I do have a source here, and these are the tables. These are the some basic tables I do have here, and I do not have anything specific as a target. I have another one, which is again similar one. It's but I added a tag called TGT. Is a target APAC AWS data mart. If I want to generate it now, it would be just a copy. But here I do have different pipelines. You see, actually, I do have all these pipelines, dim customer, dim template, dim page, dim website as well. And I do have these pipelines as well. These pipelines are to actually push my data from my virtual environment, especially my data lake, to actually Snowflake as a target. But at the same time, I can actually bring it into my environment as a source as well if somebody else actually pushing some data there. So I don't care actually what is the technology and the format of data. I can actually just plug to the sources and build a virtual environment in my environment as well. I think we should be fine for now. I built almost everything, and you can repeat the same cycle. And the good thing is, if you continue this one, you have all the steps here. So you can actually go to all the steps, and all the step actually explains how to build them. And I do have the queries, all the steps the query as well, which I can share. But of course, I will remove my user password, everything as well, which you need to build for yourself. But all the queries, everything is available, and I can replicate for yourself. I will share all the databases, all the every if you're interested, all the backend, I mean data as well. It's not the secure content, and I can share everything as well, including the queries, not just the real connection information to my cloud environment. So that's it. And back to you, George, and thanks for your time and all the audiences give me this opportunity. I think I'm done with real demo as well. It just takes 4 hours, but happy to take some questions.
Thank you so much, Ali, and thank you for pouring through. Wow, I mean, what a demo! And the one thing that really stuck to me is how easy it is to pick it up, to really learn the Lyftron data environment and get used to it, work with it. Seems very intuitive, very user friendly. And thank you for showing such a comprehensive demo. And thank you also
No,
for offering to the audience that wants to learn a little bit more and try it out themselves to do this on their own. So thank you so much for that. And Yesha, thank you so much for sticking with us. As she mentioned, this is great. Thank you, and thank you to Bija. Matt had to take off, but he really enjoyed the conversation as well. So again, thank you, everybody. I do encourage you to follow Ali here on LinkedIn. Get in touch with him if you do have any follow questions, but also check out Lyftron.com. And from what I'm aware, they offer a free trial. So do check it out, take advantage of it, try it for your own. Download the files that Ali will be able to share, and see how it can work for you. See how you can reinvent near real time digital and content analytics with data virtualization. All right. Well, thank you so much again, everybody, for tuning in, and looking forward to the next show next week. Until then, thank you again so much, Ali. It was a pleasure to have you on the show. And again, thank you for the amazing walkthrough.
thank you so much. I really appreciate this opportunity.
Have a great Thursday, everybody.
Thank you.
Bye.
Bye.